All right, today we're going to be learning more about exponentials and logs, and we're going to learn some properties that go along with them. So, if we have 2 to the x power equals 4, we would know that 2 squared is 4, so therefore x equals 2. If we have 2 to the x power equals 8, we know 2 to the third equals 8, so x equals 3. However, if we have 2 to the x equals 6, well, it's got to be somewhere between 2 and 3, but we don't know for sure that's going to be 2.5. We don't really know a way to solve this yet. And what we're going to learn about today is going to help us. So, definition of a logarithm with base b, when y is positive and b does not equal 1. So, the way we say this is log base b of y equals x. And this is compared to an exponential in the fact that if it's written in this form, we can switch it to b to the x power equals y. So what happens is logarithms were created in order to help us find exponents that we don't know. And logarithms follow a lot of the same rules that exponents follow. Now on your calculator, there's two different logarithms. The common logarithm is log base 10, and it's usually written just log of x. They don't put the little 10 down there, so if you don't see it, you should know that's a base of 10. And then the natural logarithm, which is log base e. E is Euler's number. It's a long irrational number, kind of like something similar you would know is pi. That's a long irrational number. They're similar. And it's represented ln for natural log. All right, so let's look at converting these. Our base is our little number. So if we wanted to go from log form to exponential form, 4 is our base. Logs are always equal to the exponent, and then it equals whatever you're taking the log of. So number 2, log base 5 of 125 equals 3. That would be 5 to the third equals 125. And if log base 7 of 1 equals 0, then we know 7 to the 0 power equals 1. And your way of checking all of these is type 4 to the third in your calculator. Type 5 to the third on your calculator and type 7 to the 0 power. You should get 64, 125, and 1. What if we wanted to go from exponential form to log form? We'd have log. Our base here is 3, so it's going to be down little, so it's a subscript. It's going to be near the tail of the g. Of 81 equals the exponent, because logs always equal exponents. So log base 2 of 32 equals 5, and log base 4 of 64 equals 3. So in words, what does log base 4 of 256 means? It means 4 to what power equals 256. Something that can help you with evaluating logarithms is your power sheet. Do you remember this from earlier in the year? This can be very helpful. Hopefully you guys have not lost it. So, log base 3 of 243. 3 to what power is 243? It's 3 to the 5th power. So we know that this is equal to 5. 2 to what power gives you 2? That's the first power. 5 to what power equals 1? Well, anything to the 0 power will equal 1. 4 to what power will give you a negative 2? This is not possible or not defined. You cannot take a log of a negative number. There's no way of raising a positive base to an exponent and getting a negative number. And then we have log base 1/3 of 81. Well, if we ever want to go from a fraction to a whole number, or if we had a whole number base and our answer was a fraction, we know that exponent's going to be negative, because in our rules for exponents, if we have a negative exponent, it basically means to take the reciprocal. So what we're looking at is 3 to what power equals 81, and then we're going to take that exponent and make it negative. And if we look back at our power sheet, 3 to the 4th is 81, so that means 1/3 to the negative 4 would be positive 81. So let's move on to some properties. Product property. Let's think about this with exponents. If you have x squared times x to the 3rd, what do you do with the exponents? You add them. So if you have log of two things being multiplied, you can expand them by changing it into addition. So we'd have log base 3 of 9 plus log base 3 of x. Now, with our logs, we always need to check and see if we can simplify them. Log base 3 of 9, well, is there a power we can raise 3 to get 9? Yes, it's squared, so this simplifies to 2 plus log base 3 of x. We could also condense it. That's going to help a lot when we solve equations. So if it's addition and we want to condense, we're going to go back to multiplication. So we'll have log base 2. Notice in both of these, the base stays with the log part and it doesn't change. Then x times 7 would be 7x. A lot of times people will put this in parentheses just so they know we're taking the log of that whole thing. All right, what if we are dividing with exponents? Say we had x to the 5th over x squared. We would subtract the exponents. So if we have two logs of a fraction, we can separate it into subtraction. Or if we wanted to go backwards, we could change the condense it with division. So here we'd have log of 2 minus log of 7, and your denominator is always going to be what comes second. And we don't need to show a base because this is our common log. So we don't have to write the little 10, but if you wanted to fill something in, you'd have little 10s down here. But convention is not to write those. Kind of like we just don't write a 1 in front of x when it's just 1x. And if we wanted to condense it, it would be the natural log of x over 3. And again, the first part is the numerator, the second part's your denominator. Power property. What if we had an exponent in there? So let's say we have x to the 3rd to the 4th power to another power. We multiply them. So if we have a log to an exponent, we can expand that by writing the exponent out front as multiplication. So log base 3 of x to the 5th would become 5 log base 3 of x. And if we wanted to condense it, we would take the number out front and make it an exponent, log base 2 of 3 to the 3rd. Since we know that 3 to the 3rd is 27, we're going to rewrite it as log base 2 of 27. How do you know when you should simplify things like that? If this power is written on your power sheet, you should simplify it. So 3 to the 3rd, it's right here on our power sheet. That's how we know we should simplify. In general, if it's anything higher than a 5th power, you can leave it as an exponent if you've lost your power sheet. All right, let's put them all together. We're going to expand and simplify this as much as we can. The first thing that jumps out to me when I look at this is the division symbol. So I'm going to simplify that first. So log base 4 of 64x minus log base 4 of y to the 5th. And then I'm going to look at each of the two pieces that I have now. In here, we have multiplication, so I can separate that by using addition. Minus, and because this has an exponent, I'm going to bring it down in front and become multiplication. Now I'm going to look and see if any of these pieces can be simplified anymore. Log base 4 of 64. Is that on my power sheet? Is 64 power of 4? Yep, it's right here. So that's going to simplify to just 3. So I'll have 3 plus log base 4 of x minus 5 log base 4 of y. And that's as expanded as I can get. So let's condense. So one of the last things we did here was simplify our log that we had just a number for. We don't have anything that doesn't have a log, so we can skip that part. I would look at the fact that all of these have a number out front. So I'm going to move those back and make them exponents. So log base 5 of x to the 3rd minus log base 5 of y squared plus log base 5 of z to the 6th. Notice how each log has its base. Don't lose these little numbers down here. All right, next, let's condense it all into 1. We know we're going to have a fraction because we have some minus signs in here. So log base 5 of x cubed. The first thing always goes in the numerator. The second thing goes in the denominator. And then because this is plus, we know that we need to multiply by z to the 6th, so it's going to go on top. Now, a lot of people want to be like, well, it came after the minus sign, so it must go in the denominator. If it was to go on the bottom with y squared, we would have had parentheses here. We would have had parentheses up here. Because we don't have those, z to the 6th is going to go in the numerator. And that's as condensed as this can be. All right, and our last property is called change of base. And the reason we have this is because older calculators we used to be not able to do some of the things that our newer calculators can do, and so they needed to come up with a way to do them using common logs. Or this also can be done with, if you have log base b of a, you can also use natural log for both of them on top and bottom. The big thing is the base goes in the basement. It drops down to the denominator of the fraction. All right, so if we have log base b of a, it can be common log of a over common log of b, or it could be natural log of a over natural log of b. The ratios are going to come out to be the same. So log base 3 of 5 would be log of 5 over log of 3. Log base 6 of 11, let's do it as natural log of 11 over natural log of 6. Will come out the same. Log base 12 of 24 would be log of 24 over log of 12. Now, this is very, 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 very important. This does not, I repeat, does not equal log of 2. You cannot do that. That's against the rules. Do not do this. Don't. There will be somebody on the quiz next week that does this. Don't do this. Angry face. Don't do that. You cannot simplify like that. Okay? Log of 24 over log of 12. Order of operations says you have to do the logs first and then divide the answers. Cannot divide what you're taking the log of and then take the log of them. It's not allowed. So change of base, after you rewrite it, just leave it. Don't do anything else. That's all for today. See you in class.